Hello, today's topic is going to be law of conservation of mass. Things we're going to cover today: what it is, and how it's going to be applied to balancing chemical equations. First off, what is the law of conservation of mass? It is the law that says mass cannot be created nor destroyed in any chemical reaction. Matter cannot appear or disappear when we're doing chemical reactions. What starts in the beginning of a chemical reaction, we'll call those the reactants, has to be at the end of the chemical reaction, in the products. Every single atom has to be accounted for. And atoms cannot change types during a chemical reaction. That, in a nutshell, is what the law of conservation of mass is. So let's look at an equation. We're going to take sodium and we're going to react it with chlorine. The product of this reaction is sodium chloride. Now, on the reactant side, we have one sodium atom. On the product side, we have one sodium atom. This is good. This is balanced. That means we did not create any sodium and would not lose any sodium. Balanced. However, chlorine, we have two. In the reactant side, we know there are two because of the subscript number by the Cl. On the product side, we only have one. That's not good. World's out of balance. Now, in order to make this balanced, we are going to have to add a chlorine atom to this side. Now, because this chemical formula is already balanced, we cannot just add a chlorine by putting a subscript in. We have to add an entire NaCl, an entire compound. To do that, we are going to change the coefficient. Now, we have two sodium atoms here now. That one is now a 2. If we go back to our original sodium atom on the reactant side, we have 2 on the product side, we need 2 on the reactant side. So we need to put a coefficient out front that represents 2 sodium atoms. Now the world's in balance again. 2 sodium atoms, 2 chlorine atoms, 2 sodium atoms, 2 chlorine atoms.